So we're now ready for it. I think we're ready to talk about mass, right? Mass. What is mass? Mass is the amount, here's my prop again. Mass is the amount, I'm going to eat this clementine afterwards. Mass is the amount of matter in an object, right? This object has the same mass here on the Earth, out in outer space, on the moon. It's the amount of matter in an object. We measure it, say, in kilograms. Weight, by the way, which is often confused for mass, is the force of gravity on an object. That's why we weigh a different amount less on the moon versus on the Earth. Weight typically is measured in newtons of force. It's the force of gravity on an object. So we're looking at mass. Now, the thing is, that was an interesting discussion, but it kind of doesn't matter because we're going to just go look at our processing sketch and look at a circle on the screen and think, okay, what's the mass of that object? Oh, that one looks like 0.75 to me, right? So we're just kind of making up numbers for mass. Most likely it would probably make sense to have mass be tied to the size of something we draw. So the diameter of a circle, the width and height of a rectangle, those might be values we tie to mass. The bigger it is, the more massive it is. We could get into density, which is, if it's not very dense, it's going to have a lower mass, even if it's big. But we don't need to get that far into it. All we want right now is to have objects that seem like bigger and more massive and some that seem smaller, and to see different accelerations that vary according to that object's mass, which we are ready to do. So, right, because we, did I say this already? I'm confused because I tried this before and I don't know what I'm talking about. But where we are is that we understand that that the net force is equal to mass times acceleration, or acceleration is equal to the net force divided by mass. So we've been doing that already. The net force gets accumulated into acceleration every frame of animation, every cycle through draw, but we haven't divided by mass. So, what's interesting here? When you make these videos, I'm realizing that there's something we didn't cover back with the vector videos. I'm going to go back and make a video, so by the time you see this, it'll have already existed, and it's like I went back in time and solved everyone's problems. But for right now, you need to go back and review the video on static methods in the p-vector class. Because something that's very important here is that if a force, let's just look for a second. Let's say we have two objects, m1 dot apply force. It's a little bit of a digression, but I think I'm going to go with it for a moment. Let's say we make up a p-vector f, which is some force. Right? And we're going to apply it to two objects. And in a moment, I'm actually going to change our example to have an array of objects so we can at least see a variety of masses, right? So if we're taking a force and applying it to two objects, let's just say we first wrote this code. Force